Yeah. Good evening, children. Good evening, online students.
Good evening.
Good evening.
Good evening, ma'am. Good evening,
Yeah.
ma'am.
Good evening. Yeah. Good evening, children. We finished the 10th one in the last class. We finished. Okay. All right. So continuing with understanding quadrilaterals. This is the next question. RISK and CLUE are parallelograms. RISK and CLUE are parallelograms. Find X, right? Find X. Online students, I've shared my screen. Visible?
Yes, ma'am.
Okay. Yeah. So children, in the quadrilateral RISK, let me just trace it. See it. This is the parallelogram. Okay, quadrilateral, more particularly parallelogram. This is the parallelogram RISK. See here, this one. This one is RISK. Correct? Now we know that in a parallelogram, adjacent angles are supplementary. Adjacent angles are supplementary. Angle K and angle S are adjacent angles. Look at the parallelogram RISK. RISK. This angle S. See here S and K, they are adjacent angles. So see here S and K, they come next to one another. S and K. See the name of the parallelogram SK. So angle S and angle K, they are adjacent angles and they are supplementary. So if angle K is 120 degrees, S will be 60 degrees because 120 plus 60 is 180. All right. Again, in the parallelogram CLUE, in this parallelogram CLUE, in this parallelogram CLUE, this one, in this parallelogram, U and E are adjacent angles. Oh, sorry, here we have 70, right? Okay, so L and E are opposite angles. Angle L and angle E are opposite angles. They're equal. In a parallelogram, opposite angles are equal. See here, look at the parallelogram CLUE, CLUE. Okay, so angle L and angle E, they are opposite angles. You must see the angles in the parallelogram, not from one parallelogram to another parallelogram. In one parallel, so this is the parallelogram CLUE, where angle L and angle E are opposite angles. So they're equal. So the measure of this angle is 70 degrees. Correct? Okay. So in the parallelogram RISK, angle K and angle S are adjacent angles. So we get 60 degrees here. And in the parallelogram CLUE, angle L and angle E are opposite angles and they're equal. So this is 70 degrees. This is 70. This one is 70. Now this is a triangle. This one is a triangle. We know that the sum of the three angles of a triangle is equal to 180 degrees. Now we already have 70 plus 60, 130 degrees in the triangle. So the measure of X should be 50 degrees. The measure of X should be 50 degrees. Get that, children? Understand all of you? Yeah. Please write down. Please write down, children. Hello. Please write down the answer. Please take the answer as you see in the slide, children. Don't try to work on your own. Write it exactly as you see on the screen. You can draw later, Shivam. Take down the answer first. Okay, take down the answer. Maybe I can share the picture. You can draw it at home also, if it's taking time. Inma? No, you're not audible.
Fifth sem and the sixth sem, they didn't teach us yet. The division algorithm, they didn't teach us, and this thing.
Okay, you just do the regular division for this. I'll tell you how to do the algorithm. You just do the regular long division for this one. Okay. And then you must be knowing dividend is equal to divisor into quotient plus the remainder. Okay, no problem. You just perform the long division and leave it there. Yeah. Done writing, children?
Yes, ma'am.
Okay, Aishwarya, what is this ASP?
Ma'am, can you hear me? ASP is angle sum property.
Very good. Angle sum property. Yeah. So I have marked this angle A. I've marked this angle A. This one is A. Angle KSI as A. And angle CEU. CEU, this angle as B. This one as B. So it becomes easy to present the answer. I've marked this angle A and this one as B. So 120 plus A is equal to 180. 120 plus A is equal to 180. And then angle B is equal to 70 degrees. So once you find A and B, then angle sum property. A plus B plus X is equal to 180. Once you find A and B, so A you find using the parallelogram RISK. B you find using the parallelogram CLUE. Once you find A and B, then you use the triangle. You use this triangle. A plus B plus X is equal to 180 to find the measure of angle X. Not angle X, to find the measure of X. Is MNOP a trapezium? Name its two parallel sides. So we have two lines here, MN and PO. They're line segments. So we have, if you extend them, they're the lines, and this is the transversal. So you can look at the opposite side, there's two lines intersected by a transversal. And you know that these two angles are called co-interior angles. These two angles are co-interior angles. If the co-interior angles are supplementary, then the lines are parallel. If the co-interior angles are not supplementary, then the lines are not parallel. I'll answer this question and then we'll discuss in detail about lines being intersected by a transversal and parallel lines being intersected by a transversal. Okay. So to answer this question, extend this, extend this, extend this. So we see two lines intersected by a transversal, and this angle and this angle, they're called co-interior angles. And we see that co-interior angles here are supplementary. Okay, because 100 plus 80 is 180. So the co-interior angles are supplementary, which means the lines are parallel, which means MN is parallel to PO. And if in the quadrilateral M and OP, one pair of opposite sides is parallel, then the quadrilateral is a trapezium. So is MNOP a trapezium? Yes, it is a trapezium because we have one pair of opposite sides parallel. And how do you know that they are parallel? By this check. Okay, by this check. Now name its two parallel sides. MN and OP are the parallel sides. MN and PO, or you can say NM and OP, whatever, are the parallel sides. All right. Right on. Down. Done writing? Okay. Done writing? Online students finished?
Yes, ma'am.
Okay.
Yes, ma'am.
Make the same table and do it. Yeah. So now consider this situation where we have two lines intersected by a transversal. Okay, so we see two lines. Let's name them. Two lines L and M are intersected by a transversal T. Two lines L and M are intersected by the transversal T. Okay, let me number the angles formed. Angle 1, angle 2, angle 3, angle 4, angle 5, angle 6, angle 7, angle 8. So when two lines are intersected by a transversal, 8 angles are formed around the transversal. 4 of these angles are interior angles. The remaining 4 are exterior angles. Now let's name the interior angles. Interior angles. Okay, interior angles are independent, individual angles, not a pair of angles. Interior angles is not about a pair of angles, it's about one angle. Okay, so angle 3 is an interior angle, angle 4 is an interior angle, angle 5 is an interior angle, and angle 6 is an interior angle. Interior angles are not about a pair of angles. It's about an angle. Angle 3 is an interior angle. Now exterior angles. Exterior angles. Angle 1, angle 2, angle 7, and angle 8 are exterior angles. Corresponding angles. So nothing about interior and exterior angles. They're the special names to these angles. That's all. Now coming to pairs of angles. All right. Corresponding angles. Corresponding angles is about a pair of angles. Corresponding angles is about a pair of angles. All right. Now, corresponding angles lie on the same side of the transversal. Corresponding angles lie on the same side of the transversal. One angle will be an interior angle and the other will be an exterior angle, but they should not form a linear pair. Corresponding angles lie on the same side of the transversal. One angle is an interior angle, while the other angle is an exterior angle. But these two angles should not form a linear pair. Okay, so now 1 is an exterior angle, 4 is an interior angle, and both of them lie on the same side of the transversal. But they're not corresponding angles because they form a linear pair. Angle 1 plus angle 4 is 180. Because they, you know this, right? On a straight line, when you have two angles, they form a linear pair. Because the sum of the two angles is 180. The sum of the two angles is 180. What is the measure of a straight angle? The measure of a straight angle is 180 degrees. And on that, if you have a ray like this, so then you have angle 1 and angle 2 here. So angle 1 plus angle 2 will be 180. This is what we call as a linear pair. Linear pair. Two angles that lie on the same straight line. Okay, so 1 and 4, see, 1 is an exterior angle, 4 is an interior angle. And they lie on the same side of the transversal. They satisfy everything, but they form a linear pair. So they are not corresponding angles. So angle 1 and angle 5. Check angle 1 and angle 5. Angle 1 and angle 5, they lie on the same side of the transversal. Angle 1 is an exterior angle. Angle 5 is an interior angle. And they don't form a linear pair. They are corresponding angles. They are corresponding angles. Angle 1 and angle 5. Angle 1 and angle 5. Corresponding angles. Angle 4 and angle 8. Corresponding angles. And on the other side, angle 2 and angle 6. Corresponding angles. And angle 3 and angle 7. Angle 3 and angle 7 corresponding angles. All right. Now, alternate interior angles. Alternate interior angles. Alternate angles lie on either sides of the transversal. Alternate angles lie on either sides of the transversal. They don't lie on the same side of the transversal. They lie on either side of the transversal. Alternate. So we have alternate interior angles and alternate exterior angles. Now talking about alternate interior angles. Okay, alternate interior angles. Angle 3 and angle 5. So you can see 3 and 5, they are interior angles. No, 3 and 5 are interior angles and they are alternate interior angles because 3 is on one side while 5 is on the other side. Again, they should not. Now you cannot say 3 and 4. 3 and 4, they form a linear pair. So 3 and 5. Similarly, 4 and 6. Angle 4 and angle 6. Alternate interior angles. Now alternate exterior angles. Alternate exterior angles. Angle 1 and angle 7. Then angle 2 and angle 8. And angle 8. Alternate exterior angles. And then we have a co-interior angles. Co-interior angles or consecutive interior angles. Okay, or they're also called allied angles. Let me write it on the next slide. So we have co-interior angles, also called allied angles. Allied angles. Co meaning consecutive interior angles. Allied angles. All right. Or angles that lie on this. Okay, this is enough for you. 1 second. When we get started, this is enough. Okay. Co-interior angles or allied angles. Okay. Angle 3 and angle 6. Co-interior angles. Angle 3 and angle 6. Angle 3 and angle 6. Angle 4 and angle 5. Angle 4 and angle 5. All right. Allied angles. Angle 4, angle 3 and angle 6, angle 4 and angle 5. No, your time's up. Next class, that's all. Or just do whatever you know. You finished? Wait for. Right. So 3 plus, sorry, angle 3 and angle 6. Allied angles. Angle 4 and angle 5, allied angles. Now, what do you say about angle 1 and angle 3? Angle 1 and angle 3, what are they called? Angle 1 and angle 3, what are they called? What are angle 1 and 3 called, online students? Vertically opposite angles. Vertically opposite angles. Angle 1 and angle 3. Angle 2 and angle 4. Vertically opposite angles. 5 and angle 7. Vertically opposite angles. 6 and angle 8. Angle 6 and angle 8. Yeah, correct. Angle 1 and angle 3. Angle 2 and angle 4. Angle 5 and angle 7. Angle 6 and angle 8 are vertically opposite angles. Correct? And the linear pairs we find here, angle 1 plus angle 2 is 180 because these two angles lie on the straight line L. Correct? Linear pair. Angle 1 plus angle 2 is L is a straight line. And on the straight line L, you have two angles 1 and 2. Angle 1 plus angle 2 is 180. And see it on the straight line T, we have 2 and 3. Angle 2 plus 3 is 180. Angle 3 plus 4 is 180. Angle 1 plus 4 is 180. All these are pairs, linear pairs. Angle 1 and angle 2 linear pair, 2 and 3 linear pair, 3 and 4 linear pair, 4 and 1 linear pair. Here also 5 and 6. Angle 5 plus angle 6 is 180. Angle 6 plus angle 7 is 180. Angle 7 plus angle 8 is 180. Angle 8 plus angle 5 is 180 because they're two angles that lie on the same straight line. We'll discuss the linear pair once again. Now, coming from the beginning, when two lines, so here we have two lines L and M intersected by a transversal T. When two lines L and M are intersected by a transversal T, 8 angles are formed around the transversal, 4 of which are called interior angles and the other 4 which are called exterior angles. And then we also have other relations, corresponding angles, alternate interior angles, alternate exterior angles, and allied angles or co-interior angles, consecutive interior angles. Now, all these are pairs of angles. Interior angle is about one angle. One angle can be called an interior angle. One angle can be called an exterior angle. But you cannot call one angle a corresponding angle. Corresponding angles is about a pair of angles, two angles. Alternate interior angles, two angles. Alternate exterior angles, two angles. Allied angles, two angles. All this are about a pair of angles, corresponding angles, alternate interior, alternate exterior, and allied angles are about a pair of angles. About a pair of angles, correct? While interior and exterior angles are about an angle, one angle. Okay, so when the lines are not parallel, corresponding angles are not equal. When the lines are not parallel, the corresponding angles formed are not equal. They are corresponding angles, but they are not equal. When the lines are not parallel, alternate interior angles are formed. Alternate exterior angles are also formed, but they are not equal. When the lines are not parallel, allied angles are formed, but they are not supplementary. When the lines are parallel, corresponding angles are equal, alternate interior angles are equal, alternate exterior angles are equal, and allied angles are supplementary. When the two lines are parallel. See, all these relationships exist when two lines are cut by a transversal. All this will happen when two lines are cut by a transversal. You will find all these angles. Now, when are the corresponding angles equal? There are corresponding angles, but when are they equal? If the lines are parallel. Alternate interior angles are equal when the lines are parallel. Alternate exterior angles are also equal when the lines are parallel. If the lines are not parallel, they are alternate interior angles, they are alternate exterior angles, but they're not equal. Yeah, the relationship exists, but they're not equal. Allied angles. Yes, they are allied angles. They are supplementary if the lines are parallel. If the lines are not parallel, they are not supplementary. That sum may be less than or more than 180. If the sum of the allied angles is exactly 180, then that means the lines are parallel. If the sum of the allied angles is less than 180 or more than 180, they are allied angles, but the lines are not parallel. If the lines are parallel, the sum of the allied angles will be exactly 180. If the sum of the allied angles is less than 180 or more than 180, they are allied angles. But the lines are not parallel. That's why the sum is not 180. So when two parallel lines, when two parallel lines are intersected by a transversal, then the corresponding angles are equal. See, these angles, corresponding angles are equal. If this is 70, this is also 70. If this is 110, this is also 110. If the lines are not parallel, these are corresponding angles. But this will be like some 110, this may be 60, but they are corresponding angles, but they are not equal. They're not equal because the lines are not parallel. Hundred and ten, this angle and this angle, by the position, they are corresponding angles. But the lines are not parallel. That is why the angles are not equal. But if the lines are parallel, the angles will be equal. Alternate angles will be equal, corresponding angles equal, and then co-interior angles or allied angles, they may be equal, but they are supplementary. They're equal when they are 90 degrees each. 90, 90, they'll be equal and supplementary. Otherwise, they're only supplementary. They will not be equal. They're equal and supplementary in the case of 90 degrees, 90, 90. So they're supplementary and they're equal because 90 each. Otherwise, it will be like 120, 60, 70, 110, something like that. So when lines are parallel, allied angles are supplementary. When lines are not parallel, allied angles are there, but they are not supplementary. Then what will it be? Their sum will be either less than 180 or more than 180. Corresponding angles, they are there. When two lines are intersected by a transversal, there are corresponding angles. But if the lines are not parallel, the corresponding angles are not equal. If the lines are parallel, then corresponding angles are equal. So now, using this theory, here we have two lines intersected by a transversal. We have two lines intersected by a transversal. The angles in this position and this position, and this position, they are allied angles. And we see that they are supplementary also. These two angles are allied angles. And we also notice that they are supplementary. That means this line should be parallel to this line. That's why they are supplementary. So these two lines are parallel. That means it's a trapezium with MN and PO as the parallel sides. Understood, children? Online students?
Yes, ma'am, understood.
Understood, ma'am.
Got it, ma'am.
Very nice. All right, over to the next one. Yeah, I think you can just make a note of these. Take the diagram on the right side. Yeah, and write out these angles, meaning to the left side. Don't take it down as you see in the presentation. Draw the diagram to the right side and write the details on the left side. Like in the rough column, the diagram, and then the main work. Name all these angles, interior, exterior, all this, whatever you see here, and also allied angles. Yeah, please start writing this.
Done, ma'am.
Oh.
Done, ma'am.
All right. Yeah, see. Yeah. Allied angles.
Done, ma'am.
All right. Finished?
Done, ma'am.
Yeah. Now, these relations exist, these relations exist only when two lines are intersected by a transversal. Okay, so if you use the term interior angles, exterior angles, corresponding angles, alternate interior angles, alternate exterior angles, allied angles, that means there are two lines intersected by a transversal. Only then these relations are formed. These terms are used only when two lines are intersected by a transversal. Now, vertically opposite angles and linear pair, they are not a result of two lines intersected by a transversal. They exist even otherwise. So we'll see that here. You're still writing, no? You're done or no? Finished? Okay. Now consider the situation where two lines intersect. Okay. So two lines intersect like this. When two lines intersect, vertically opposite angles are formed. Now let me call the lines P and Q. Okay. So you can see that P and Q are two intersecting lines. P and Q are two intersecting lines. See, how do we name lines? Either you take a point A, a point B on this and call it the line AB. Or you can name the line using any small letter. For that, you should not take a point on the line. See, a line can be named using any small letter of the English alphabet. Okay, so you can call it line A, line B, line C, line D, line E, line F, line G, line L, line P, Q, small letter, not capital letter, small letter. Then you should not take a point like this. This line is line F. See you. Yeah. Thank you. Okay, but if you want to name, if you want to take points and name the line, then it will be like this. Then take a point P, capital letter, take a point Q, and this is line PQ. This is line PQ. I have used small letters. So this is line P, this is line Q, and they intersect at this point. So when two lines intersect, if two lines intersect, they're not parallel lines because they're intersecting lines. If they're parallel lines, they'll not intersect. Parallel lines will not intersect, right? Yeah. These are two intersecting lines. When two lines intersect, vertically opposite angles are formed. So when do we have the situation of vertically opposite angles? Vertically opposite angles are formed when two lines intersect. When two lines intersect, vertically opposite angles are formed and they are equal. They're always equal. Vertically opposite angles are always equal. They're formed when two lines intersect. So these two lines P and Q intersect. Vertically opposite angles are formed and they're equal. So see, this angle is equal to this angle. So if this is 40 degrees, this is also 40 degrees. And this angle is equal to this angle. What will be the measure of this angle? What will be the measure of this angle? $140. 140 degrees. The measure of this angle is 140 degrees because you can see that this is a straight line. Q is a straight line. Q is a straight line. And see here, 40 degrees is one angle and this is the other angle. So the sum of these two angles will be 180. So this is 40. The remaining will be 180 minus 40, 140 degrees. See here. This is 40 degrees. This one is 40 degrees. Now, this is a straight line. No, this one is a straight line. On the straight line, we have a ray like this. So the sum of this angle and this angle is 180. On a straight line, if you have a ray like this, the sum of this angle and this angle is 180. Because this is a straight line. And so this is a straight angle. See here, this is a straight line and there's a ray on it. So the sum of this angle and this angle will be 180. So here this is a straight, this is a straight line. So there's one angle 40 degrees. So this 40 degrees and this angle, they form a linear pair. So this one will be 140. So if this is 140, the opposite angle here, this also will be 140, linear pair. So this one is 40 degrees. This is 40 degrees. Now see here, from here to here, this is a straight line. See here, from here to here, this is a straight line, right? See here, from here to here, this is a straight line and it's a straight angle. So it's 180. Of that, this is 40. So the rest of it will be 140. Now, if this is 40, this is 40. Vertically opposite angles are equal. And if this is 140, this is 140 because vertically opposite angles are equal. Now, linear pair, see here, angle 1, 2, 3, and 4. Angle 1 plus 2 is 180. Because it's a straight line. See, from here to here is a straight angle. From here to here is a straight angle. So angle 1 plus 2 is 180. See, this is a straight line. This one is a straight line. So angle 2 plus angle 3 is 180. Because this is a straight line. This one is a straight line. So on the straight line, we have angle 2 and angle 3. So 2 plus 3 is 180. Now this is a straight line. This one is a straight line. And on the straight line, we have angle 3 and angle 4. So angle 3 plus 4 is 180. Similarly, angle 1 plus angle 4 is 180. Linear pair. So this is a straight line. There is a ray on it. Now the sum of these two angles will be 180 because they form a linear pair. That means there are two angles on a straight line. This one is a straight angle which measures 180 degrees. So this angle 1 and angle 2 form a linear pair because their sum is 180. This is the next question. In the trapezium given below, AB is parallel to DC is given. In the trapezium, AB is parallel to DC. Find the measure of angle C. So how much is C, children? Find the measure of angle C. This is measure of angle C. So now this is parallel to this. And this is the transversal. Correct? This is the transversal. So what kind of angles are this angle and this angle? What is the relationship between this angle and this angle? Parallel lines, transversal. There is an angle here and an angle here. What is the relation between these two angles?
Co-interior angles.
Co-interior angles or allied angles, yes. And it's given that the lines are parallel. This line is parallel to this line. So when two lines are parallel, allied angles are supplementary. When two lines are parallel, allied angles are supplementary. So if this is 120 degrees, measure of angle C is 60 degrees. 180 minus 120, 60 degrees. It's given, see here, AB is parallel to CD. These two lines are parallel and this is the transversal. So this angle and this angle by the position are allied angles. By the position are allied angles. And when the lines are parallel, allied angles are supplementary. So if this is 120 degrees, this is 60 degrees. Correct? Oh, sorry. Yeah, take down.
Done, ma'am.
Yeah.
Done, ma'am. So whenever we use the property of parallel lines, you need to mention the parallel lines and the transversal. You need to mention the parallel lines and the transversal. So here AB is parallel to DC and BC is a transversal. Angle B plus angle C is equal to 180 because they're allied angles or co-interior angles, and they're supplementary because the lines are parallel. If the lines are not parallel, they're not supplementary. So how do we read this? Line segment SP is parallel to line segment RQ. Line segment SP is parallel to line segment RQ. Find angle P and angle S. So we have parallel lines here. So we have parallel lines. You can just extend them to understand better. You can just extend them to understand better. So these are the two parallel lines. And see, at a time, you must consider two parallel lines and one transversal. So let's take the parallel lines and this transversal, this transversal. All right. These are the two parallel lines. These are the two parallel lines. And this is the transversal. So what do you call these two angles? This angle and this angle, they're allied angles. They're allied angles. They're allied angles. So they are supplementary. So if this is 90, this also will be 90. Here, parallel lines, transversal. This angle and this angle, they're allied angles. Because here, these are the four interior angles. These are the four interior angles. Now, these are co-interior angles. And these are co-interior angles. And co-interior angles are supplementary. So if this is, if angle R is 90, this one is also 90. S is also 90, this one. Similarly, the same two parallel lines, but a different transversal. PQ is a transversal. The same two parallel lines, okay, but a different transversal. PQ is a transversal. Again, this angle and this angle, they're allied angles. Because see, they're interior angles. Allied angles are what? They're interior angles. They lie on the same side of the transversal. Allied angles are interior angles because co-interior angles. So both of them will be interior angles and they lie on the same side of the transversal. So these two angles you can see, they are interior angles and they lie on the same side of the transversal. So they are supplementary. If this is 130, this is 50 degrees. You need to consider two parallel lines and one transversal at a time. So to answer the first, to find angle P, parallel lines and transversal, this one is a transversal. Angle Q plus angle P is equal to 180, allied angles, because parallel lines, no, allied angles are supplementary. So this is 50. To find angle S, the same two parallel lines, but a different transversal. This angle plus this angle is 180, allied angles. So if this is 90, this also is 90. So here you see that the allied angles are equal because 90. But here you see that the allied angles are not equal, 130 and 50. Here it is 90 and 90. Yeah, right on, Chetan. Please mention the parallel lines and the transversal. Done writing? Finished online, children?
Yes, ma'am.
Yes, ma'am.
Yes, ma'am.
Okay. Draw a quadrilateral that is not a parallelogram, but has a pair of opposite angles equal. You must draw a quadrilateral. It should not be a parallelogram. That means what? Opposite side should not be a parallel. Opposite sides should not be parallel, but it should have one pair of opposite angles equal. Can you name the quadrilateral? Can you name the quadrilateral that satisfies these conditions? Okay. Now, Lakshana will tell us the quadrilaterals we have seen so far. So I'll start. Trapezium. Then Lakshana, name all the quadrilaterals you have seen so far.
Ma'am, rhombus,
Rhombus,
rectangle,
rectangle,
square,
square,
kite,
kite,
trapezium,
trapezium, and parallelogram.
yes, ma'am.
Correct. So kite, trapezium, parallelogram, rhombus, rectangle, square. Now, which one of these will satisfy these the conditions here? A quadrilateral that's not a parallelogram but has one pair of opposite angles equal. It should always have one pair of opposite angles equal. See the properties we have taken down. Flip back the pages. Check from the properties. It should not be a parallelogram. So the answer is not rhombus, rectangle, or square because it should not be a parallelogram. So the answer is not rectangle, rhombus, or square. Then what are the remaining two? Trapezium and kite. But in a trapezium, can you always say that one pair of opposite angles are equal? No. In a trapezium, you cannot say that one pair of opposite angles are always equal. Then check the properties of a kite. No, it doesn't take this long, children. Check the properties of the kite and see if you have this property that one pair of opposite angles are equal. Oh, it doesn't take this long, children. You haven't written that? Haven't we written? Okay, 1 second. Let me just pick that.
Ma'am, on the properties of kites, it says that two angles are equal where the unequal sides meet.
Yeah. Where the unequal sides? Yeah, read that.
The two angles are equal where the unequal sides meet.
Yeah.
So,
the two angles are equal where the unequal sides meet. And that is
opposite
a pair of
angles are
opposite
equal.
angles. Correct. That's the pair of opposite angles. You see here. So this is one pair of equal sides. This is the other pair of equal sides. Okay. This is one pair of equal sides. This is the other pair of equal sides. Where do the unequal sides meet? See here, this one and this one. These are the unequal sides. They meet here. And this are the unequal sides. Where do they meet? They meet here. And these angles are equal. You can see them in the properties. The angles where the unequal sides meet are equal. And that is the pair of opposite angles which are equal. So it's a kite. So kite is a quadrilateral that satisfies this condition. See your children. These two sides are equal. These two sides are equal. This is how a kite looks, no? This is how a kite looks. These two sides are equal. These two sides are equal. The unequal sides, so this side and this side, they meet here. So this angle, this side and this side, they meet here. So these two angles are equal. And that is a pair of opposite angles. So in a kite, one pair of opposite angles is always equal. The other pair is not equal. The other pair, this one, not equal. This one, not equal. Okay, so a kite is not a parallelogram. A kite is not a parallelogram. Because in a parallelogram, both the pairs of opposite sides are parallel. In a parallelogram, both the pairs of opposite sides are parallel. But in a kite, no pair of opposite sides are parallel. A kite is not a parallelogram. A kite is not a parallelogram. And in a kite, one pair of opposite angles are equal. Which is that pair of opposite angles? The angles formed by the meeting of the unequal sides. Where the unequal sides meet, an angle is formed. Those two angles are equal. Okay, so, but the question is, draw a quadrilateral. So you should draw.
Ma'am, I'm done with writing question number 15.
Okay. Done? Yeah. In a quadrilateral ABCD, in a quadrilateral ABCD, this is a rough sketch. In a quadrilateral ABCD, angle A is 60 degrees, angle C is 70 degrees. Is ABCD a parallelogram? Yeah. Is ABCD, can you call ABCD a parallelogram? Angle A is 60 degrees, angle C is 70 degrees. Can this be a parallelogram? What are the properties? What is the property related to opposite angles in a parallelogram? If it is a parallelogram, then opposite angles are
Equal.
equal. If it's a parallelogram, opposite angles should be equal. Clearly, angle A is not equal to angle C. Angle A is not equal to angle C. Angle A is 60 degrees while angle C is 70 degrees. Opposite angles are not equal. So if opposite angles are not equal, it cannot be called a parallelogram. It is a quadrilateral, but it cannot be called a parallelogram because we see that the opposite angles are not equal. And while marking, you should mark, see here, A, B, when you draw the quadrilateral A, B, you must not mark C and D here like this. A, B, C and D like this in the anti-clockwise or the clockwise direction. You must not mark A, B here and then C, D like this. Yeah.
Done, ma'am.
Yeah. You can take the rough figure which I've shown.
Now my laptop is running low of charge. Can I just be excused for a few minutes to get the charger?
Sure. All right. Next one. In a quadrilateral ABCD, just draw a rough figure. Okay. ABCD. In a quadrilateral ABCD, AB is equal to CD. AB is equal to CD is equal to 7 centimeters. Okay. This is just a rough figure, children. ABCD is a quadrilateral. AB is equal to CD is equal to 7 centimeters. BC is equal to 4 centimeters. And AD is 4.5 centimeters. Is ABCD a parallelogram? Is it a parallelogram? No. Why? Yeah, you're right. Tell me. Correct. Because in a parallelogram, both the pairs of opposite sides are equal. In a parallelogram, both the pairs of opposite sides are equal. AB will be equal to CD as well. AD will be equal to BC. Both the pairs of opposite sides should be equal. Here, one pair of opposite sides is equal, while the other pair is not equal. So it's not a parallel. You cannot call this a parallelogram. It's a quadrilateral. It's not a parallelogram. Because in a parallelogram, both the pairs of opposite sides must be equal. Yeah. Okay. Next one. In a quadrilateral ABCD, angle A plus angle C is equal to 180. Is ABCD a parallelogram? In a quadrilateral ABCD, angle A plus angle C is equal to 180. Is ABCD a parallelogram? So you can't say this information is not sufficient to conclude if it's a parallelogram or not a parallelogram. Because earlier see, in the earlier questions, now in this question, it's very clear that in this question, in question number 16, see the board, in question number 16, it's very clear that opposite angles A and C. In this question, it's very clear that the opposite angles A and C are not equal. In a parallelogram, both the pairs of opposite angles are equal. But here in this question, angle A is 60 degrees while angle C is 70 degrees. Clearly, opposite angles are not equal. Then it cannot be a parallelogram. You can say for sure because both the pairs of opposite angles must be equal if it's a parallelogram. Here it is not. One pair is not equal. So even if the other pair is equal, so I'm saying supposing even if the other pair is equal, it's still not a parallelogram because both the pairs of opposite angles must be equal. And here we can say for sure it's not a parallelogram because if it's a parallelogram, both the pairs of opposite sides must be equal. Not just one, both pairs of opposite sides must be equal. Here one pair equal, the other pair not equal. So it is not a parallelogram. But here, this information is not enough to conclude because we don't know about the sides, we don't know about the opposite angles. It's just given angle A plus angle C is 180. It may be a parallelogram, it may not be a parallelogram. So this information is not sufficient. The information is not sufficient to conclude if ABCD is a parallelogram or not a parallelogram. Right with the question?
So in these type of questions, we cannot say it can be a parallelogram or it cannot. So we have to write the answer as may or may not.
Yeah, ABCD may or may not be a parallelogram. I have just given, but it's a trapezium, but it's not, you don't have to write this also. This is not required. This is not required. This is not required. It's not relevant. Just ignore this one. ABCD, the question is it a parallelogram? So with this information, it's not easy to conclude if it's a parallelogram or not a parallelogram. So this is the answer. ABCD may be a parallelogram, may not be a parallelogram. The given information, you can also write like this. The given information is insufficient to decide if ABCD is a parallelogram or not. The given information is insufficient to decide or to conclude if ABCD is a parallelogram or not a parallelogram. Done, children?
Yes, ma'am.
Okay. Two adjacent angles of a parallelogram are in the ratio 2:1. Find all the angles. So this one is a parallelogram. Two adjacent angles are in the ratio 2:1. Okay, so let the angles be 2x and 1x. Don't write the answer. I'll show you the slide. We'll just understand first. Okay, the angles are in the ratio 2:1. Adjacent angles are in the ratio 2:1. So let us consider this angle and this angle. They are a pair of adjacent angles. You can take angle A and B, or angle B and angle C and angle D, or angle D and angle A. Any pair of adjacent angles. Okay, they are in the ratio 2:1. So let this angle be 2x and let this angle be 1x or simply x. Now you have to construct an equation. And what will that be? We know that in a parallelogram, adjacent angles are supplementary. They are supplementary. So that means angle A, it's given as a parallelogram. Angle A plus angle B is equal to 180 because they're adjacent angles. They're supplementary in a parallelogram. So 2x plus x is equal to 180. So 3x is equal to 180 or x is equal to 180 by 360 degrees. So x is 60. X is 60. So 2x will be 2 into 60, 120 degrees. I don't. So once we find x, angle B is 60 degrees. So angle A will be 2 into 60, 120 degrees. The question is find all the angles. So opposite angles are equal. So this will be 120 and this will be 60. Done writing, children?
Yes, ma'am.
Okay. What is the property about adjacent angles in a parallelogram? In a parallelogram, adjacent angles are supplementary. And if they are equal, what will be their measure? Adjacent angles are supplementary. And they are also equal.
The 90 degree.
Yeah, 90 degrees. So that will make every angle 90 degrees, right? Because opposite angles will be equal. So all
Yes,
the four
ma'am.
angles will be 90 degrees. So then what do you call that quadrilateral? But what do you call the parallelogram?
Square.
Rectangle. No, we cannot say it's a square because it's a parallelogram. Only opposite sides are equal. So you can for sure say it's a rectangle. It may be a square. We can't say because it's only a parallelogram. In a parallelogram, opposite sides are equal. And now when every angle is a right angle, it's a rectangle. We can't say it's a square because in a square, all the sides should be equal. But this is a parallelogram. Only opposite sides are equal. So in a parallelogram, when every angle is a right angle, it's a rectangle. In a parallelogram, when every angle is a right angle, it is a rectangle. In a rhombus, if every angle is a right angle, it's a square because in a rhombus, all the sides are equal. And if the angles are 90 degrees, then it's a square. Because all sides equal, angles 90 degrees, it's a square.
Done, ma'am.
Yeah. So mark of any pair of adjacent angles, mark of any one pair of adjacent angles. So I have taken angle A and angle B. Angle A and angle B are adjacent angles and they're equal. So I've called them X. X. Now what is the relation? In a parallelogram, adjacent angles are supplementary. So X plus X is equal to 180. Why have we named them X? Because they're equal. Now X plus X is equal to 180 because adjacent angles are supplementary. So when you work that, you get X is 90. That means angle A is 90, B is also 90. If A is 90, angle C is also 90. Opposite angles are equal. If B is 90, D is 90 because opposite angles are equal. ABCD is a rhombus. You need to find the values for X, Y, A, and Z. So quickly tell me what will be the measure of A? A is an angle. A is an angle. It's given that ABCD is a rhombus. What will be the measure of this angle, which is called A? 90 degrees. A is equal to 90 degrees because we know that in a rhombus, the diagonals are perpendicular to each other. In a rhombus, the diagonals are perpendicular to each other, which means the measure of A is 90 degrees. A is 90. And what about X? X, we know that the diagonals bisect each other. AC is a diagonal. O is the midpoint of AC. OA is equal to OC, right? In a rhombus, diagonals bisect each other. OA is equal to OC. So if OC is 5, OA is also 5. So X is equal to 5. Similarly, the other diagonal BD. O is the midpoint of BD. OB is equal to OD. OB is equal to OD. So if OB is 12, OD is also 12. So Y is equal to 12. And then Z. I'll tell you how to find Z. Online students. Anantika, Lakshana, Harsha.
Mom, I understood that A is equal to
Shreya.
90 degree. I'm not able to understand how you found the others.
Okay. Yeah. So that's using the properties.
Same,
Correct. Okay. So in a rhombus, diagonals are not equal. Diagonals are unequal. In a rhombus, diagonals are unequal, but the diagonals bisect each other. That means one diagonal cuts the other diagonal into two equal pieces. In simple words, both the diagonals have the same midpoint. O is the midpoint of AC. O is also the midpoint of BD. In a rhombus, diagonals are unequal. They're not equal. The length of AC and the length of BD will not be the same. O is the midpoint of AC. O is also the midpoint of BD. That's what we mean by saying the diagonals bisect each other. So if O is the midpoint of AC, if O is the midpoint of the diagonal AC, that means the line segment OA will be equal to the line segment OC. See, AC is a diagonal, and O is the midpoint of AC. So if OC is 5, then OA also will be 5 because O is the midpoint of AC. which means x is equal to 5. Similarly, the other diagonal BD. BD is the other diagonal. O is the midpoint of BD also. O is the midpoint of BD also. That means if O is the midpoint of BD, BO will be equal to OD. How much is BO? BO is given to be 12. That means OD will also be 12, which means Y is 12. Shall I repeat it, children? Or is it understood now? Online students?
Yes, ma'am, understood.
Understood, ma'am.
Okay. AC is a diagonal. AC is one of the diagonals. You can see the point O on AC. O is the midpoint of AC. OC is given to be 5. That means OA or AO, this also will be 5. That means X is 5. The diagonal is BD. BD is other diagonal. O is the midpoint of BD. We know that OB is 12. It's marked. It's given. OD will be 12, which means Y is 12. And A is 90 degrees because in a rhombus, diagonals are perpendicular to each other. So this is 90. The value of A is 90 degrees. Now we have to find Z using Pythagoras theorem. Or we have to find Z using Pythagoras theorem. See, in a rhombus, there are 4 right triangles. In a rhombus, there are 4 right triangles. This one is a right triangle because this is a right angle. This one is also a right triangle because this is a right angle. This one also is a right triangle because this is a right angle. This one also is a right triangle because this is a right angle. Now consider the right triangle BOC. Consider the right triangle BOC. We know BO is 12 and OC is 5. Now, how do you apply Pythagoras theorem? Pythagoras theorem can be applied only in a right triangle, not in every other triangle, only in a right triangle. Now, square the hypotenuse. Which are the 3 sides of this triangle? BC being the hypotenuse, OB and OC are the legs. OB and OC are the legs of the right triangle. Now, Pythagoras theorem goes like this. Square the hypotenuse, BC square. Square the hypotenuse, BC square is equal to square the other 2 sides, OB square, OC square, and add them. So the square on the hypotenuse is equal to the sum of the squares of the other 2 sides. The square on the hypotenuse is equal to the sum of the squares of the other 2 sides. Let me write it again. In a right triangle, the square of the hypotenuse. So which is the hypotenuse? BC. The square of the hypotenuse is equal to the sum of the squares of the other 2 sides, OB and OC. Okay. Write the hypotenuse, square it, equal to the remaining 2 sides are O and OC, OB and OC. Square them and find their sum. This is Pythagoras theorem. Now substitute the values. So we have BC square is equal to how much is OB? 12. 12 square plus OC 5 square. What is 12 square? 144. 5 square 25. 144 plus 25 169. So we have BC square. BC square is equal to 169. So BC is equal to the square root of 169. BC is equal to 13 because 13 into 13 is 169. 13 times is 169. So the length of BC is 13. The units are not here, so 13 units, meaning centimeter, meter, nothing is mentioned. So we'll just say 13 units. That means Z is equal to 13. Z is equal to 13. See here the letters X, Y, A, and Z Okay, A represents an angle. X, Y, and Z sides, not sides, line segments. X, Y, and Z represent line segments, while A represents an angle here. Correct? Yeah, take down them.
Done, ma'am.
Yeah.
Done, ma'am.
Yeah. Finished. Yeah. ABCD is a rectangle. Find X. Now, in a rectangle, diagonals are equal. In a rectangle, diagonals are equal. In both a rectangle and in a square, diagonals are equal. Listen to me. So in this rectangle PQRS, diagonal PR will be equal to the diagonal QS. Diagonals are equal. And in all parallelograms, rhombus is a parallelogram, rectangle is a parallelogram, square is also a parallelogram. So in all these figures, the diagonals bisect each other. In parallelogram, rhombus, rectangle, square, diagonals bisect each other. That means O is the midpoint of PR, O is also the midpoint of SQ. O is the midpoint of the diagonal PR. O is also the midpoint of the diagonal SQ. All right. Now, so diagonals are equal here, right? So supposing the length of PR is 20 units. So it will be 10 here and 10 here, correct? Now, if PR is 20 units, SQ also will be 20 because diagonals are equal. So which means, and again, O is the midpoint of SQ. So it will be 10 here and 10 here. Yes or no? Okay, let's take another case. Diagonals. Diagonals are equal. Remember that. Diagonals are equal. Remember that. Okay. A, B, C, D. O is the midpoint. See here. O is the midpoint of BD. O is also the midpoint of AC. Remember that. And diagonals are equal in a rectangle. Now, supposing AC is 18 centimeters. 18. So AO will be 9 centimeters. OC will be 9 centimeters. But we know diagonals are equal. So the diagonal BD also will measure 18 centimeters. And O is the midpoint of BD. So it will be 9 centimeters here and 9 centimeters here. So what do you see in a rectangle? All these line segments, OA, OB, OC, OD, all are equal. In a rectangle, all these line segments, OA, OB, OC, OD are equal. In a square also they'll be equal, but not in a rhombus or parallelogram. They'll not be equal like this. All these four line segments, OA, OB, OC, OD, are equal in a rectangle and in a square. So what's the equation here? So we know that OA is equal to OD, correct? So that means 3x plus 1 is equal to 2x plus 4. So 3x minus 2x is equal to 4 minus 1. So x is equal to 3. The value of x is equal to 3. We have any issue with the solving part? 2x comes here as minus 2x. And minus 1 as, plus 1 as minus 1 to the other side. So 3x minus 2x is x. 4 minus 1 is 3. Now, consider a rhombus. Consider a rhombus. This is a rhombus, children, not a kite. It's a rhombus. Diagonals are not equal. Supposing this diagonal is 30 centimeters, it will be 15 here and 15 here. But diagonals are not equal. So maybe this is, say, 20 centimeters. So it will be 10 here and 10 here. So if I mark it A, B, C, D, A, B, C, D, and O here, you see that OA is equal to OC. All the four are not equal. OA is equal to OB is equal to OC is equal to OD is not true here. OA is equal to OC. Then OB is equal to OD. But all the four are not equal, I'm saying. Yes or no? But in a rectangle and in a square, OA is equal to OB is equal to OC is equal to OD. Yeah. Yeah. Please work. can show the steps. So 3x minus 2x is equal to 4 minus 1.
Ma'am, for verification, we can substitute x with 3 and we could solve it, right, ma'am?
Yeah. Yes. So what do you get? 2 3s are 6, x plus 4, 10. 3
Yes,
3s
ma'am.
are 9 plus 1, 10. 10. Yeah. So OA is 10, OD is 10. So then what's the length of the diagonal AC, Aishwarya? What is the length of the diagonal AC?
It will be 20 centimeter, ma'am.
20, correct. Because if OA is 10, OC is also 10. So 10 plus 10, 20. AC is 20. Done? Yeah. Okay. So you can see from the, don't write, don't stop. No. 1 minute. Okay. Children, please listen to me. So you can see that in this quadrilateral ABCD, both the pairs of opposite sides are parallel. It's marked. It's not given, but it's not given that ABCD is a parallelogram. But you can see from the, the parallel lines marked. See, this side is parallel to this side. Also, this side is parallel to this side. So from this, you can make out that both the pairs of opposite sides are parallel. So ABCD is a parallelogram. It's marked. It's marked here that this pair of opposite sides is parallel. And from this, you can make out that this pair of opposite sides is parallel. So both the pairs of opposite sides are parallel, and hence ABCD is a parallelogram. So you can use all the properties of a parallelogram here. All right. Okay. Now, it's given that this portion is equal to this portion. That means when you produce this, see, if you supposing, if required, if you produce this will be the midpoint. Because see, it's given that this portion is equal to this portion. That means this should be the midpoint. If this one is equal to this one, you understand the marking, no? If it's marked like this, it indicates that the two line segments are equal. So if this portion is equal to this portion, that means this is the midpoint. This is the midpoint. You can mark it O if you want. Okay, now let's read what we have to find. Angle D. You need to find the measure of angle D. This one, this angle D. Angle D is this full angle D. Okay, so this is 55 degrees. So how much is this one? By linear pair, how much is this one? By linear pair, how much is this one? 180 minus 55. 180 minus 55 because it's a straight angle. On the straight line, you have a ray like this. This is 55 degrees. So this one will be 180 minus 55. 125 degrees. This is 125. And now in parallelogram ABCD, opposite angles are equal. So if this is 125, its opposite angle D also will be 125 degrees. See, it's very easy to identify a linear pair, children. Straight line. So this is a straight triangle. This one is 180 degrees. Now at this point, if you have a ray like this, if you have a ray, this angle and this angle, this makes a pair of angles. And it's called a linear pair because they stand on a straight line. The sum of these two angles will be 180. This one is 55. So this will be 180 minus 55, 125. Okay, so this is 125. So this is 125, children. This is 125. Opposite angles are equal, right? In a parallelogram. So angle D is 125. No, I want to know if you are following or are you following, children? Online students?
Yes, ma'am.
Why do we say that ABCD is a parallelogram? How do we conclude that ABCD is a parallelogram? It's not mentioned in the question, but how do we know it's a parallelogram? It's marked that opposite sides are parallel, so it's a parallelogram. Okay. Now, how did we find this one? This one to be 125. What's the property? Linear pair. Linear pair. This angle plus this angle is 180. So this is 125 linear pair. And then how did we find D? Opposite angles are equal. In a parallelogram, opposite angles are equal. So this is 125. Now, how will we find angle C? The next one is to find angle C. How will you find angle C? What's the property here? Very good. Adjacent angles are supplementary. In a parallelogram, adjacent angles are supplementary. Angle C plus angle D is equal to 180. Or you can say alternate angles are equal. See a parallel line, transversal, parallel line. Alternate, see a parallel line, transversal, parallel line. Alternate angles are equal. So if this is 55, this is also 55. Alternate angles are equal. Why are these lines parallel? Because we know that they're the opposite sides. See here, it's marked. So you can find out angle C using the property of alternate angles. This angle is equal to this angle, 55 degrees. Alternate angles are equal. Or adjacent angles are supplementary. Angle C plus angle D is equal to 180. So if this is 125, this has to be 55 because adjacent angle is supplementary. Next is line segment AC. The length of the line segment AC. How much is AC? AC, this one.
Ma'am,
AC
it
is
will
the
be
diagonal.
18 centimeter.
AC is
18 centimeter.
18 because it's marked 9 here, 9. So this also will be 9 centimeters. It's a parallelogram. So this is the midpoint of this diagonal. So if this part is 9, the other part also will be 9. So the length of the diagonal AC is 18 centimeters. 9 plus 9, 18 centimeters. Now your question will be, how do you know that this is the midpoint? It's not given. How do you know that this is the midpoint? Because you can see it's marked here. These two portions, they're marked equal. That means this has to be the midpoint. And we know that in a parallelogram, both the diagonals have the same midpoint. In a parallelogram, rhombus, rectangle, square, both the diagonals will have the same midpoint. So that means when you produce this, this is the midpoint of AC also. This is the midpoint of AC also. So in AC, if this portion is 9, the other portion is also 9. So 9 plus 9, 18. AC is equal to 18. And what about AB? AB, what's the length of the line segment AB? 20, because the opposite sides are equal. If this is 20, this is also 20. DC is 20. So AB also will be 20. Opposite sides are equal. And what about BC?
15
BC?
centimeter.
15. BC is 15. Again, same property. Opposite sides are equal. If AD is 15, BC is 15. All right. Okay, children, since it's time, I'll share this image on WhatsApp. Online children have an option to take a screenshot now. I'll also share this image on WhatsApp. Complete this answer before you come to the next class. All right, children. So that's it for today's session. Thank you so much. Good night. You may leave the call, online students. Thank you, children. Good night.
Thank you.
Thank you.
Thank you.
Thank you, children. Good night.
This is Aishwarya.
Yeah.